Hello friends, I Agrawal AS, Assistant Professor in Civil Engineering Department. Today's topic is Analysis of Continuous Beam by Moment Distribution Method. Now, next step is this is the continuous beam ABCD. It is subjected to loads different in the different span. Now, the first step is to calculate the KI of the beam. So, KI of the beam is the IB and IC because here is a rotation of possible. So, IB and IC. So, here we can apply the condition of equilibrium, that is the sigma MB and sigma MC. Now, the next step is to calculate the distribution factor. We know that for the joint A and joint D, because of fixed end, the distribution factor is 0. So, we have to calculate only the distribution factor for the joint B and C. So, now here is a table: joint, member, related to stiffness, total stiffness and distribution factor. Now, for the joint B, member is BA. So, BA and the BC. For the joint C, member is CB and the CD. Now, this second letter is the far end. A, C, B, D, these are the far ends. So, BA, so look at the A here. So, this is the far end. So, that why here relative stiffness is the R by L. So, this value is the 0.4. Now, for the B to C. So, here C, we want one more is support. So, treat this support as a fixed support. That is why here the relative stiffness is the I by L. So, put here the value of I is equal to I and L is equal to 7. So, that is equal to 0.142 I. Now, for the C to B. So, one more support is there. That is why treat this as a fix. So, for the fix, when the far end is a fix here, in that case, the relative stiffness is the I by L. So, that gives the value 0.142. Also, C to D, again this D is a fix. So, here the relative stiffness is the I by L. So, that gives the 0.4. So, now here this is the total stiffness, that is the at the B, BA and BC. At the C, CB and CD. So, here is 0.542 I and here is a 0.42 I. Now, the distribution factor is what? Individual stiffness, that is 0.4 divided by the total stiffness, that is the 0.542. So, that is equal to 0.73 here. Individual stiffness 0.14 divided by the 0.542. So, that gives the 0.27. In the same line of action here, also the individual stiffness divided by the total stiffness gives the value 0.27. For CD, again individual stiffness 0.4 and the point divided by the 0.54, that gives the value 0.73. Now, here next is the temporary resistant the support. Consider each span as a separate fixed beam. So, apply resist both the ends and find out the fixed end moments. Now, here this is the anti-clockwise movement. So, anti-clockwise movement produces the anti-clockwise fixed end moment. The formula is MB by L square into twice B minus A. Here, why this is minus? Because this moment is the anti-clockwise, that is why here minus. Here also this is anti-clockwise, that is why here minus, because we know anti-clockwise movement produces the anti-clockwise fixed end. So, now put the value into this formula. So, we will get here the minus 4.80 and minus 12.80. In the same way, consider BC as a separate fixed beam, and here these are the fixed end moment M bar BC and M bar CB. We know this formula WAB square by L square, and here is WA square B by L square. Now, important is what here this sign is minus because this moment is the anti-clockwise, and this is plus because this moment is the plus. So, this gives the minus 58.77 and 44.08. Then same consider the span CD as a fixed beam. Again, find out here the fixed moment. We know this is the sagging moment. So, this is the Hockey moment. So, WL square by 12 here, WL square by 12 here, both is the because the symmetric of loading, minus because of this anti-clockwise, and this is plus because this is the clockwise. Now, put the value into this M.D.M table. That this first row is the joints, second row these are the moments, third row is the distribution factors, and fourth row that we have calculated the fixed moment that enter below the BA, BC, CB, CD and the AB. Now here no need to balance because here the 0 DF and at the D, DF is 0. That is why no need to balance the support A and D. So only we have to balance the support B and the C. Here is the unbalance. Here is the minus 12.8. Here is the minus 58.77. So summation of sigma MB is not 0 here. Also sigma MC is not 0. So we have to balance the support B and C. How? The first cycle. Here unbalanced moment at the joint B, that is the here M bar BA and M bar BC, that is equal to minus 71.57. So here is a minus, so apply here the plus 77 plus 71.57, but according to the distribution factor of BA and BC. So here the moment share by BA is 52.242 and moment share by BC is equal to 19.328. In the same way at the joint C, unbalanced moment is what? M bar CB and M bar CD. So that is equal to the 2.41, but here is a plus. So apply here the minus moment at the joint C, but according to the distribution factor of CB and CD. So moment is shared by CB, that is equal to the his balancing moment into the distribution factor. So that is equal to minus 0.650 and here for CD is minus 1.759. Now enter this all value into the M.D.M table. How? Look in this table here. The previous table. This was our previous table. Now here the balancing moment at the joint B, BA and BC. Here is the CB and the CD. Now next step after the balancing, next step is the carryover. Carryover occurs when the far end is a fix. So at the BA, so A is here a fixed end. So carryover half here. During the carryover, the moment, the direction is the same, but magnitude is the half. So here is a half carryover to A. Also the intermediate support C is a fix. Also intermediate support B is a fix. That is why here half carryover to A B, half carryover to C. In the same way here half carryover to D, because this end is a fix. If the end is simply supported, then there is a no carryover. Only in the case of the if the far end is a fix. In that case only the carryover moment, and that always is the half, but direction is the same. So here this value is minus, so this value is the again the minus. Now go for the second cycle, because this becomes the unbalanced here due to the carryover. So this is the unbalanced moment, minus 0.325. So apply here the plus 0.325, but according to the distribution factor BA and BC. So moment share by BA, that is equal to 0.237 and moment share by BC, that is equal to 0.088. Here what 0.325 is the balancing moment and 0.27 is the distribution factor. In the same way joint C, this is the unbalanced moment that we have seen in the previous. This is the unbalanced moment 9.66. So here 9.66 is unbalanced moment. So apply here the minus 9.66, but according to the distribution factor of CB and the CD. So moment share by CB is equal to minus 2.60 and moment share by CD, that is equal to minus 7.06. How it is? Here is a balancing moment into the distribution factor. Now enter this value into the table. So now here these are the balancing moment that we have calculated previously: 0.237, 0.88. Then here is a minus 2.60. Here is a minus 7.06. So again, once the support is balanced, we have to carry over all this cycle till all the balancing moment should be the value less than the 0.1. So that gives the satisfactory result. So again the next step is the carryover. So carryover to D, carryover to B, carryover to C and carryover to the A. Half is the carryover always. So here sign is the same, but magnitude is the half. So again these two support becomes the unbalanced. So again we have to balance the support B and the support C. So again next step same here, unbalanced moment at here is a minus 1.3 and so apply here the plus 1.3, but according to the distribution factor BA, that is equal to share moment is 0.95 and for BC that is the 0.35. Here is a balancing moment into the distribution factor. In the same way, unbalanced moment at the C that we have seen here is 0.44. So 0.044. So balancing moment is minus 0.44, but according to the distribution factor of CB and the CD. So moment share by CB that is equal to the minus 0.011 and moment share by CD that is equal to minus 0.033. So enter all this value into the table here. 0.95, 0.35, minus 0.011 and minus 0.033. Again we have to carry over because this value is quite large. So again carry over to B, C, D and the A because all the ends are the fixed. So again this both the support become the unbalanced. So again we have to balance the support. So we have to do the next cycle, that is the fourth cycle. So we know here is a minus 0.05 because here is minus 0.45 and here is a minus 0.175 is a plus. So here is a plus 0.175. This is a minus, so apply here the plus, apply 0.005 at the joint B, but according to the distribution factor BA and BC. So moment share by BA that is equal to 0.0037 and moment share by BC that is equal to 0.0013. In the same case here, same way, joint C unbalanced moment is 0.175. So here we have to apply the minus because it's the plus, so apply here the minus, but according to the distribution factor of CB and CD that is the 0.27 and the 0.73. So moment share by CD that is equal to minus 0.047 and moment share by CD that is equal to minus 0.128. Now put all this value into the table. So here 0.0037, 0.0013, minus 0.047 and minus 0.125. Now here this support is again the balance. So here we can stop because all the values are less than the 0.1 and this value is the near about the 0.1. So here we are stopping the cycle. Now how to calculate the final moments? So final moment for the AB that is equal to the summation of all the moments in the column AB. Then final moment of BA that is equal to the summation of algebraic summation of all the moments in the column BA. In the same way, algebraic sum of all the moments in the column BC. In the same way, we have to do the summation of all the moments in the column CB. In the same way, CD. In the same way, DC. So these final values, this last row shows the final value of the moments. Now here is a plus and this is a minus and both magnitude is the same. So we can say that here the sigma MD is equal to 0. In the same way we can say that here the sigma MC is equal to 0. We know here we can apply the condition sigma MB equal to 0 here. We can apply here the condition sigma MC equal to 0 because here is a kinematic indeterminacy, that is the rotation. Here the Ki is equal to 0, that is why these value are the column summation of all the moments in the column DC and here is the summation of all the moments in the column the AB. In this way the last row shows the final moments.